Hey Tim, why is this so dark again? I mean, it's very bright here. Okay, so what I've done here is I have blocked this here. Yeah, in the middle position, so that we can, see if what we are gonna do is gonna provide us with, I guess, a good geometry. So let's see. Where is a steering link? Here. So let's see. What are the options? One option would be to mount this one here. Yeah, the way I had it before. Let's do this. Yeah, let's do this and see what did I do before. I had this one, this and this. I'm gonna use dark bluish, light bluish gray pieces, because otherwise it's just gonna be black on black on black. Nobody's gonna see anything. Yeah. Hey, Maxim. Let's see. This is not perfect, obviously, but let's see what's happening here. We have slight, with this configuration, we have slight toe in. Wow, it even focused. Let's see about the bump steer. Do we have bump steer? Will you focus this, please? Not the background. This. Thank you. Yeah, we have some bumps there. Yeah. Okay. Okay. Yeah, obviously we would like this here. This so basically we want this link here to be, well, as parallel as this. Problem is that we would like to basically raise the part on the chassis here by half a stud, our usual measurement, of course. And raising this here will also get rid of the toe in, maybe, and it should give us, let's say, no bump steer, maybe. How do we raise this by half a stud? I don't know. One option would be that we lower this here, which means that we would tilt the whole wheel carrier to allow for this without really affecting the geometry. Basically, we would use this here, and this would basically shift these two. Well, it wouldn't shift them. It would basically just make the wheel carrier tilt forward, so that everything here would be straighter, and this would allow this point here to be lower. We are gonna try this, obviously. Since it's an easy fix, we're gonna try it to see. It doesn't cost us anything, just a few seconds of time to change it. And then we'll see if this is a good change or a bad change. I'm gonna leave this out for now. Okay, so the toe in is still present. Toe in is still present. Let's see about the bump steer. Whoa, it's gotten worse. Okay, it's gotten worse. Bump steer's gotten worse. Okay, that's not okay. Okay, so let's check it out. Oh, well, it's same. I mean, we have bump steer. It's not okay. Okay, let's see where the point is where we don't have bump steer. What's the configuration where we don't have bump steer? Because the toe is an easy fix. We can do, can just do this. We can use a straight lift arm instead of the half a stud offset. It's gonna be fine. So we are not gonna stress about this too much. Obviously, I need a connector. So now I'm just experimenting. It's okay. Let's see. Imagine that. Less bump steer. Not zero, but less. Even though we have a very adventurous setup, we have less bump steer. For reasons unknown to me. I'm sure the geometry somehow. Let's see. Yeah, much less bump steer than before. Still some, but it's less. It's less than before. Okay. Interesting. What if we move this lower even by a little bit more, by half a stud? What about now? Almost zero bump steer. Okay, let's move this inside. Let's use this here. What are we gonna use here? I'm gonna use this here. We're experimenting here, so This is not a final version of anything. We're just experimenting with geometry. Okay. Now we have this here. And this here. So basically the same as before, just a half a stud the outside. Now we have, to the surprise of no one, we have toe out. What about bump steer? Almost imperceptible. There is very slight bump steer, let's say, very slight. What about if we do this? Now toe is 0, but bump steer is... Wow. What? This works? How does this work? Can someone explain to me why does this work? Wow. Okay. Hold on. What am I missing? Okay, we have some bump steer, yeah. Now it's going, instead of inside, it's going outside. Okay. I was holding it wrong, manipulating the result. Okay. It's kind of hard. Okay. Cool. Okay. I don't, at this point, I don't notice bump steer. Don't notice bump steer, and I'm really holding it in a way where it should. I'm not really manipulating anything. Maybe there is slight, but imperceptible. We are like this. Okay. Okay. So with this in mind, now we need to straighten the wheels out. I mean, if we go back to this here, we're gonna end up with the same thing, but instead of toe out, we're gonna have a slight toe in, I think. But what we really want is, we want to go closer here. Since we want a bigger turning circle with a 90-degree movement of the servo, we need to move this point here closer. Let's see what happens. Like this. This is not optimal, of course, because now the multilink is acting up because we don't have enough control. Yeah, so we have to be here. Have to be here. Otherwise, you don't have enough leverage here on anything. Even this is sketchy, in my opinion. Even this is kinda sketchy. What would we do here? Ideally, we would move everything as close to the lower pivot point as possible. But we kinda cannot, because if we move the steering rack, if we move the steering rack, so from here to the other side, we suddenly get steering ratio changes. So direction changes. So basically, we don't want that. We also cannot move the steering rack lower, so the whole steering box lower, because if we moved it lower, we would have to move it by 2 studs. So that then the servo would be reversed, but everything else would be reversed as well. So it can be only here. Okay. Let's unblock it for a second and see what happens. So let's see what kind of movements we can expect, even though we still need to fix the toe out. What kind of movement can we expect by turning it 90 degrees? Okay, 90 degrees means full lock. Never mind this lift arm, which we need to change because it's long, since we're just experimenting. Okay, that's full lock. That's pretty good for 90 degrees. What about the other side? Ah, come on. The other side, the other side, not so much. Not so much. So, let me show you. So it's 90 degrees either side. So this is obviously the toe out here plays a role. Keep in mind. So the toe out plays a role. This is too much. This is never gonna be like this at 90 degrees. And this is not enough. But if we consider that it has toe out, it's gonna be a bit more here and a bit less on the other side. But yeah, let's lock it again and think about the toe out. We don't want the toe out. Let's see. Maybe we can fix the toe out together with the bump steer. Obviously, I'm gonna use this again. So this is gonna be pushed to the outside. So we're gonna get a toe in again. Yeah. So now we have a toe in, which is less than we had with the toe out. But I can feel bump steer. I can feel bump steer with it. Yeah, definitely. Definitely, we have some bump steer. I think. Or was I manipulating this? Maybe. Okay. Okay, I cannot see bump steer. Interesting. But we want... Basically, we want more toe out. So let's go back to this again, and we should have... Let's see. We're still not neutral. Still not neutral. Even though the link is now... Come on. Ah, flashlight. Disturb. Come on. Oh, really? Now you want... Oh, fucking hate this. Come on. Sometimes those buttons just don't work. I don't know why. Okay. Obviously, some of the slack here is kind of masking what we have. But let's see. Yeah, we do have turn toe. We do have toe in. Let's use this as a marker. So it's easier to spot. We have some toe in. It's not exactly parallel to the rest. And at this point, if I compress this, let's put the wheel on. It's probably more realistic. Let's put the wheel on. Doesn't have to turn, so it doesn't matter. Yeah, we get some. We get some to out, yeah. So bumps here, basically. So close yet so far. So close yet so far. What could we do? What could we do? So we basically need this point here to be slightly more in than it is, but not in the center. We don't want it in the center of this, but also not half a stud out. I have just one word for this. Well, it's two basically. God damn it. Yeah. Just gonna Bible something. Okay. Okay. So theoretically, just theoretically, this could work. It won't, of course, because we don't have the room here, but theoretically this could work. This, see, this would put it in just slightly more, I think. Or am I wrong? No, I think it would be just slightly more. Slightly more in this, so it would push it out, so it would not have toe out. Toe in. But mounting this here, in a way that would even work. Don't think that's possible. I don't think that's possible. So what do we do? Does anybody have any suggestions? just to see. Okay, so this is in the middle. Now let's try 90 degrees this side. That's pretty good. And 90 degrees to the other side. That's also pretty good. It's middle. Yeah. Well, I would rather slam it into the wall than use a single lift arm here. So single A-arm. Because then it's gonna be even wobblier. You cannot even fix it anywhere. Just gonna wobble more. This is wobbly because we have not determined the final position for this. When this point here is fixed, so it cannot move, this is gonna be as strong as it gets. Um, let me experiment. Mhm. Wow. Okay. The this current setup, the bump steer is beyond this, beyond good and evil. Okay, beyond good and evil. What if we reverse this? If we reverse this, since they are so close, we have a chance here. We have a chance. Come on, I saw you before. Okay, I'm gonna experiment with this just so you can see what's happening. Hmm? Almost. Almost. We still have some problems. Let me think. Let me think. Mhm. Mm. So ideally, what we want is we want this link and this link to be parallel, or almost parallel. So I'm going to move this part here half a stud to the back. This is gonna raise it, but let's see what happens. Let's see what happens. Need to figure out how to move it half a stud to the back. You know, just to experiment. No, no, no. There's no previous design. This is very, very specific to what we're doing here. Very specific. Yeah, I mean. Okay. Keep in mind, we're just experimenting. This is just fooling around. Whoa. Okay, this made it worse. This made it worse. Okay, let's revert back to what we had before. Okay, let's try this. Yeah. It's always that problem. So I want to move this half a stud lower than it was. The same axis but half a stud lower. Okay, how could we make this half a stud lower? How could we make this half a stud lower? Problem is, we need to keep those two So we cannot have an axle hole anywhere here. If we could have an axle hole, we could use this here, no problem. But then we have no way of mounting this. Then we have no way of mounting this. Now we could use this here. But then we have collision with the spring. Maybe. Let's try. Let's try. Why not? Again, just trying out geometries. Nothing more. Yeah, this sucks. And this is very slightly better. Very slightly better. Very slightly better. So one half a stud lower still. Okay. Can do. Can do. Yeah, I can. I can get a wheel on that. That's not the problem. Okay, we still have to out. But bump steer is no more. Okay. At least something. No more bump steer, but throw out is no more. I mean, we still have toe out, but bump steer is eliminated. Don't ask me how, but somehow this geometry creates it. Yeah, but we still have a nasty toe out. Which, if this was a real car, you would have a threaded rod here, on which the knuckle is connected to, and you just turn the rod and bring this in. Job done. But we don't, so what do you do? So if we move this here, doesn't change anything. This is nasty. So basically, there's so much slack in the system here. That's not okay. Let me just think for a second here. Let's try something. This is not gonna work, but I just want to try it. this, this is not gonna work. I just want to see the effect of this. Okay, oh yeah. So basically I wanted to see what happens if we move the steering rod lower. So closer to this. And yes, this is much better. This is much better. Everything else is shit, of course, but this at least is much better. Hmm. Let's try this. Let's see. Okay, we get collision here, of course, obviously. We have toe in now. Slight toe in, less than before. You see what I did here. Okay. What a shame that we cannot use this here. What a shame. If we could pin the tie rod here and then pin it here, that would be so great. But we can't, because this is gonna turn and we have no way of connecting it. There is a piece that would theoretically fit in here into a pin, but we discovered that that piece is just falling out. So that's not gonna happen. Such a shame. Or ideally, that we would have a steering rack that's shorter and has the link for this here. But the old steering racks have the problem that they don't have a full pinhole. They have a half. So basically, they have a pinhole that's the height of a thin plate. Thin. I mean, you know what I mean. So these basically, these. But we don't have other lengths of the steering rack. Even if we did, we couldn't use it because it would hit the steering box and then we wouldn't have enough travel. In this case here, what we can do, for experiment's sake, of course, we can, since this is a slight toe in, What if we move the steering box one stud further forward? This should eliminate the collision that we have here, and it should move this just slightly out. So because we ideally we would have a pinhole, here. We can't. But what if this works? The worst thing that could happen is it's not gonna work. I am going to use I'm gonna make a connector for this. I'm gonna, just for test sake, I'm gonna pin this. No, servo won't collide. Servo is much lower. Yes, servo will be a little bit one step further forward, but we are gonna deal with that. Okay, we're gonna deal with that. First, we need to see if this change even helps us. If it doesn't help us, the debate is over anyway. Ah, of course. Of course. Yeah, sure. Making super complicated. Super complicated connectors just to move this forward. What can I do? I could have done this easier, but I don't know. I felt like this. Okay. So basically, this is now one step forward. Problem is I cannot fix this in place. I need to hold it with my hands. Where is that? Okay, this is the magic. This. This. Yeah. Wow. Okay. Holy. So moving it forward created toe out. Okay. Toe out. Interesting. Pump steer is not present, which is good, but the toe out is a problem. No. We have quite a bit of it. So by just by moving it forward, we went from very slight toe in too a lot. Hmm. Hmm. Come on. Okay. What if? What if we used half a stud here? Move this half a stud further back. Place for my fingers. Okay. What about this solution? Let's see. Okay. Toe in. Okay. Bump steer is not present. That's good. What about steering itself? Okay. This seems to work nicely. Okay. What about the 90 degrees? So it's 90 degrees to one side. Okay. Not great, but not terrible. And 90 degrees to the other side. Terrible. Terrible. Mm -mm -mm -mm. The steering box needs to go back to its original position. Come on. Come on. Okay. Okay, what if we do the other extreme? So we angle it forward a little bit. A little bit more. Okay. This is just an experiment again. When I wish that we could do something. Oh, one step further up. And I wish we could do something like this. Okay. Steer. Some. Or no. No. Have to out. No. Oh my god. Look at this. It's just not doing anything. I can do this. And the link is just irrelevant. Oh. Okay, that's not gonna happen. Just want to test something. So, okay, this doesn't happen in this situation, but it's still. See this? Still, it's like rubber. Okay. Yeah. Okay. What I'm gonna do here is I'm going to make sure that this here is upright. This no longer like this. It has to be upright. Again, for testing, for science. And then we'll see what happens. So the geometry of the links is not gonna happen. Not gonna change. It's just this that's gonna change. Okay. So we can see what happens. If anything. Oh, come on. Okay. Just basically want to see if the same phenomenon happens in this setup. The geometry is wrong, but you know, this happens the same. No, it doesn't. Look at that. It doesn't happen anymore. This is suddenly straight. We don't have toe in or toe out, and bump steer is almost gone. Basically, what needs to happen is these two need to move half a stud to the rear. Yeah. And then this should be okay. Yeah. So basically, what do we need to do here? Well, to the rear front, we need to move them there in this direction. Hmm. Well, Ben, I understand where you're coming from. I do, but I don't agree. Okay, this is now perfectly upright. The geometry shouldn't be different. What happens is that this is now shifting so we don't get problems with this here, or not as many, I guess. Mhm. Ooh, that would be brilliant. That would be brilliant. No. Let's find a way to make it happen. You know, we are so close from greatness, so close. Just a tiny little bit is missing, and you would give up. Just a tiny bit is missing. Let's find a way to make this happen. It's not impossible. position here, then these two turn. These two turn. They're not supposed to turn. The front is also realistic because we are basically making stuff that is impossible to make with single arms. So the A arm, is hugging the spring, and we have A arms front, low in the lower section and in the top section. Just let me concentrate a little bit to see if I can come up with a way to do this. There must be a way. Okay. We still have bump steer and toe. Well, I don't know. I mean, the only way forward here or backward actually is to try what Ben said. Okay? Um, I hate it very much because the geometry is a mild catastrophe. Mild catastrophe. I mean, it's horrible. It's gonna be. We're gonna have a lot of scrub radius and everything. But we can at least try to see something. The lower A arm will be massive. The upper A arm, we'll see. We are also gonna have to change the structure here. Especially the lift arms on the bottom. They have to be completely different. Yeah. That's, I mean, we can try it. We can try it. Yeah. What else is there to do? I don't care about Ackerman. I bet original didn't have Ackerman. I am more concerned with scrub radius. Scrub radius is my main concern, basically. So this has to go. This has to go. This has to go. This has to go. Well, not entirely, but it's gonna be different. It's gonna be different because we're gonna use this here. Use this here, and here in the front, since we don't have to use this here, we are gonna use hold on. Okay, we're gonna use this here, like that. Yes, and then what? Then we got this, a niner. If we are gonna use a niner, we can use this here because this is gonna make our life when we mount the servo. Where's the servo? Yeah, much easier. Yeah, so we're gonna use this here. We're gonna do something with this here. Yeah, let's see. Yeah, we'll see. We'll see. Let's give it a try. Let's give this a try. The worst thing that can happen is that it's not gonna work. Yeah, we cannot use this. What does the title say? What does the title of the stream say? Tell me. Oh, right. Wrong link. No, that's not the gearbox. It's the front part of the car. It's the front. And we are going to do a radical thing. Okay, problem with what I just did is I don't know where the axis of the wheel is, so I need to consult the rack on the floor to see. So let's see, where is the center of the wheel? Ish. Approximately here, which means okay, center of the wheel is in here, basically. That's the center of the wheel. Okay. Okay. Center of the wheel is this dish, give or take. Right. So we need a lower A arm that is 7 studs in length. And the upper A arm is gonna be 5 studs. Yeah. And the steering link is gonna be 6 studs. So it's gonna be in the middle. And we want to use the same spring as before. The wheel hub with this sloped stuff is gonna stay. Only thing that is gonna change is, of course, that we are gonna use the bottom part. We are gonna use just this here. At the top part, I don't know what exactly we are gonna use, so I'm gonna leave this open for now. Where is our steering link gonna be? We'll also see. So I'm also gonna leave this open. But our lower pivot is this here. Very unfortunate. That's what we have on the charger. It hurts me to just see it, because the kingpin now has to be like this, just so that we can have the steering axis on the ground in the wheel. Otherwise, if we go Lego's way, it's gonna be like this. No way. Even slightly realistic, it's gonna be still outside of the wheel, so we have to go extreme. hate this, but that's how it has to be. Okay. I have no idea whatsoever how we're gonna mount the lower suspension arm, but there's possibilities. We can change this part here for this again, and suddenly we have mounting points, so not too worried about this. The lower suspension arm has to be, as we said, 6 studs. And we do want to have an option to mount the spring into it. But as before, the spring needs to be as close to this as possible. And the upper arm is going to be on the side of the spring. So whatever we do here, it's going to be on the side of the spring. Which is horrible, but that's what it's gonna be. Whatever. Okay, so let's start with the spring. It doesn't have to be in the center, so we can do this. So we can have it 1 stud lower from the start. Like this. Let's check this. Okay. This is gonna be fine. Yeah. So if we have something bumping into it, you will also ask why I'm using these springs, because I like them, because they are not incredibly hard and they have a large they have a lot of travel. The small hard ones are horrible because they are so hard, they put a lot of strain on everything. It's so hard to compress, and you have to make everything beefier because of them, and that puts on weight and everything. These are much better. They're not perfect, but they are much better than the small ones. And the closer we have the spring to the wheel hub, the better the effect of the spring as well. So the closer it is, the more direct action. The most direct action would be if this was a McPherson suspension, but it's not. But this is as close as it gets, I guess. Okay. So we said 7 studs on the bottom, okay? We'll see, yeah. We'll see. First we need to build it. First we need to build this. So we have 1, 2, 3, 4. So this is what is too much. 3 and 5. No, that's not good. Okay, yeah, that's the length that we want. That's the spring angle that's allowed. It's fine. Okay. Okay, that will do. That will do. Okay. This needs to be 5 studs. Basically, we can turn this around, I guess. No, what? Okay, yeah. Yes. Yeah, still plenty of room on either side. Okay, and the spring is as close to the hut as it's humanly possible. So we have 3 here, and we need 3 here. So on the lower arm should be 5 studs. So 5 studs wide, and 7 studs long. And these here need to be open because we are gonna pin it like this. I mean, if we use this, but then this is gonna give us just problems. This is just gonna give us problems. Yeah, we'll see. We'll see. We'll see. We'll see when we're there. Mm, okay. So now we can pin this from either side. question is, how do I pin it? So we are gonna pin it like this. So it's gonna be, if you can imagine, it's this position that it's gonna be. So one stud above the floor and one stud out of this lift arm. There are several options to pin it, but I want something that's solid, not just. Unfortunately, this thing here has an axle hole and not a pinhole. If it had a pinhole, it would be perfect. Because this way we can only do this. We can only do this, and probably we are going to do this because, I mean, it sucks, but that's the only way I see this happening. Now I'm looking basically where it needs to be pinned. So this here is approximately the center of our wheel, which needs to be where this pin is. You can see it, where this pin is. Here. So, but I at the same time I need to use this in a way so I can pin the lift arm going out there and pin it to the frame. So I'm not entirely free to use whichever option is available. So ideally, we are going to move this. We're gonna have a lift arm with, a arm with 5 studs of width, but it's gonna have 3 studs here. There. Now we can pin this like that, and this is basically as strong. It's as strong of an lower A arm as possible. If you want to move this, you're moving the chassis. It's gonna be here. Yeah. Okay. Okay, this goes. Huh? Okay. These are no-go, which is very unfortunate. Very unfortunate. Obviously, we're gonna pin these here to the chassis here somewhere, so that we are not gonna be able to pull this out. So somewhere, I don't know. Let's see. Or we're gonna just, yeah, under the steering, we can just put a lift arm through it. It's gonna be fine. So a pinhole here, and on the other side, and we just put a lift arm under the steering rack, and it's gonna be, well, it's not gonna be okay, because then the lift arm is gonna interfere with these. Well, we'll see. We'll see. Something's gonna happen. Okay. Okay, it's here. Spring can mount here. Love me or hate me. So now for the top arm. Top arm needs to be 5 studs long, and it's gonna mount in the same axis as this here. So basically, it's gonna be on the same axis as this, somewhere here. Let's see. But obviously, it's this. The spring is exactly where the top arm needs to be. So what we could do is use the top arm made out of two of these. You know why? Because the spring is here. To get around the spring. Otherwise, the caster is gonna be, if we have the lift arm here, we can have it here. So basically, the caster is gonna be adventurous, to say the least. So we have a nice, solid, really solid lower arm, and we are probably gonna use this. Yeah. So best of both worlds, let's say. Best of both worlds. So we can nicely go around the top arm and be, you know, well, we have to be probably even closer. So here, like this. Yeah. But we also want them to be as low as possible. Yeah. So we tilt this a little bit. We want this where do we want it? Approximately here-ish. This is not enough. Yeah. More. More. I want to go more in here, not here. Have I lost you completely? I'm lost. No, I don't think so. Maybe. Maybe. I mean, I ordered them. We can still redo this. We can still redo this. Yeah. Maybe. Maybe, yeah. Maybe the upper arm could be made with these balls that you are showing, and connectors only. So we would have the upper A arm made out only out of connectors. That would be a possibility. Yeah. That would be a possibility, and would even look all right. Yeah. That is a possibility. But first, I need to get them. They are on the way. I need to check the tracking number, the tracking info, how far they are But yeah, when the Kata parts arrive, that's gonna be interesting. Yeah, that's gonna be interesting. So many new parts to play with. Yeah, exactly. And then we would have like this here, and then 45 degree. So where are they? I have them on the desk. They are looking at me. Mm, yeah, maybe not like this. Or maybe this. You know, we could have like this and another one, and then a connector at the end. Maybe, or to make them look good. Or we could just use some connectors to get around the spring. We'll see. Mm, yeah. Now I want this to be the other lift arm, of course, because this has to be closer. Yeah. Yeah, we'll see. We'll see what we gonna do. Come on. Mm, no, this makes it vertical. Vertical. Wow. Okay. I would prefer those Kata pieces, to be honest. No. Double wishbone, of course. Countach has double wishbone. Here, after all. Mm-hmm. 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 No power steering at all. Really? Okay. I did not know that. That's weird. But I guess. Mm. Higher. With the Kata pieces, this is gonna be different, of course. Um, but at the moment, we have to get it higher. Yeah, like this. Yeah, to clear the spring. Mhm. Interesting. Because they were so light. Yeah. So we have caster definitely. The issue here, of course, is clearing this. But when we have the color parts, this is not going to be an issue because this is going to be a constant point, not moving, so it's not gonna be a problem. We have well, we have camber changes. Yeah, makes sense. Yeah. So this would be right height, which is fine. Yeah. Yeah, it slips out. Unfortunate. Yeah, barely, barely. This is actually, in our case here, it's counterproductive. It's counterproductive because it moves the axis here. It moves the axis. Let me put two of these together. So it moves the axis that goes through here, and it goes like that. Now, because of the pivots here, we get this here. So instead of the axis going like this, even this, yeah, we get this here. So we don't have, the scrub radius is wrong. So these are wrong. The spring needs to be mounted further in so that these here can move. And we do need the Kada part. Now, what are the odds of the Kada parts arriving by Friday? I would say low. Very low. Which is unfortunate. And I don't know how to make a fake part. So that we could, you know, have the part without having it. Just for now. I guess what I could do is if I butchered one of these and glued this part here to a pin, that would maybe allow us to have the part without actually having it, and then we can develop this before we get the Kata part. So I think I'm going to butcher one of whatever I have here. Cut socket from a lift arm. What? What do you mean cut socket from a lift arm? Glue a pin on said socket. Don't get. You mean this socket? So if I would sacrifice one of those, yeah, probably not the new ones. I'm gonna use one of those 5.5 stud ones. Cut the cut, yeah, because on Friday we need to move forward with this, so we need the part, and yeah, we're gonna make one just so we can develop this, and then we're gonna replace it with the actual part. Yeah, this is still shit, even with the part here. It's still gonna be shit, but it is what it is. This is frustrating. But what can you do with shitty hub designs? What can you do? Very little. Very little. It would be so easy to make this one stud closer. So fucking easy. But no. Nope. Someone decided that this bearing here really needs this support here. That it really needs this support here. Which is hollow, by the way. This is not solid. This is hollow. Doesn't really support anything. If this was flat, it would be perfectly fine. But you could put a ball joint here. You know? You could. Oh man, I don't have any. Ah, okay, here it is. So. We could, if this was flat, we could put a ball joint in, but we can't. Come on, focus. Come on. Yeah. Should be flat. Almost flat with pinholes, because the amount of support it gets here is minimal. It rides on the edge. Um, so I don't understand this. Really. This could be so much better. Ball shaft. What? What ball shaft? What ball shaft? Problem is that whatever you have here, you can barely fit this in. You can barely fit this in. And then of course you cannot pivot in this way because someone didn't think about it. You can only pivot in this way, but and you cannot do this. So you're boxed in either way. But this would make a difference with other designs. So yeah. I don't know. And we're not stuck. What we're doing here, we're not stuck with this. We can use the charger solution as well. So we'll see. So something like this, this hub. We'll see what we're gonna do. But first we need this ball joint here. Yeah, I'm gonna make it till Friday, and yeah, that's it for the stream. Thanks for watching, for bearing with me here. It was unbearable today. And yeah, we'll see what we can do on Friday. We'll see. I do not like this, but what can I do? Anyway, thanks for watching, and see you on Friday.